Hello guys, welcome to Data to Deploy channel. My name is Arash. In this video, I want to talk about Pandas library, a very important library for data scientists and data analysts. So if you are data scientist or data analyst, or you love to learn more about these topics, Pandas is one of the very important library you will use day to day in your workflow. When you want to read a data frame, work on data frame, data sets, Pandas help you and let you manage your rows and columns and your features more easily. So I have written an article about this on my website Data to Deploy. I will put the link in the description. 12 Pandas tricks in Python to boost your data science and your data analysis skills and boost your workflow. You can check it. You can copy these all codes and learn more about this library in this blog. Also, I put all the codes in my GitHub account. I also put this link in the description. You can also visit this one too and use these codes. For this project, for this video, I want to use Google Colab. I will use Google Colab because Google Colab is a very good option for data exploration, because we run each command separately on separate capsules, so we can see the result of each capsule before running another command. For example, if you use VS Code, you should run all of your code in one file, and then you will get the end result. You can't run separate capsule to get for example, this capsule wants to show us a data frame. The next capsule wants to show us a for example, linear chart. Okay, so when you run your code on Google Colab, you can see each one separately and in order. So here, as you can see, first we need to import our libraries. We use Pandas and NumPy. Mostly we use Pandas, and here we mention as PD because in future, for example, here as you can see, instead of calling the pandas each time, for example, instead of you writing pandas dot set option, you just simply write pd.set option, so it's easier and faster to write your codes. First, by clicking on this button, we run this command. Here we got checked, and now we want to work on our tricks. The first trick is using set option. So normally when you want to read your data frame, it may be too large, for example, have lots of rows or lots of columns, or for example, on the default, the background of data frame is white. With pd.set option, you can add any option you want. For example, here we wrote display max rows 50 or max columns to 20. So at maximum, we see 50 rows of data frame and 20 columns of features. And for example, in data frame, which we will see soon, some columns are numerical and some columns are categorical. So numerical ones may be integer or float. Float integer number, let me write here. Integer numbers are like 1, 2, 3 or 11, 150 and these. But float number are like, for example, 1.123 or 45.678. Okay, we call these numbers float. Okay, so we can put this option that just show until two decimal of float numbers. So for example, if our column or row have a value 45.678, with this line it turn it to this. Okay, it will only show the last two, the first two decimal to appear on your data frame. Okay, we run this, and also here I should tell you this, if you later want to reset your settings, your option settings, you can simply run pd.reset option, for example display.max row or max columns. With these set options will be reset and cancelled. Okay, so for this example I comment these two and we run this. And the next part is to defining our data frame. So there are lots of ready and real world data frame data sets. You can find it, or you can write your own data set. Okay, based on what project you are working on, you can choose it. For this one I create a data frame using e-commerce data. Here, as you can see, it's a dictionary. In Python we call this type of values and key and values a dictionary. We call this key and we call these values. Okay, so for example, this is our column and this is the values. This is the next column, for example customer, it's customer names, Alice, Bob, Charlie. Next is product, for example laptop, phone, monitor. Next one is category. Next one is quantity. Next one price, region, and tags. Okay, we run this, and right now we have a dictionary. Okay, so how we can create data frame out of our dictionary? Simply by writing pd.dataframe, and inside parentheses our dictionary name here is data, and we give it a value df. Okay, and also we can do some feature engineering. For example, total amount, which we cross quantity to price. Okay, so for example each laptop here is $120. Okay, and quantity is 1. If for example for the next one the phone quantity is 2 and the price is $800, the total amount will be 160. Okay, we generate another feature, and after that we can see our data frame shape. Okay, let me run it first. Here, as you can see, we are seeing in the parentheses 15 and 9. What this means: if you run the data frame itself on Colab, you can just simply write your data frame name and run the capsule, and the data frame will appear. Here, as you can see, we call these lines row, and these columns features are columns. Okay, so these are rows and these are columns. So df.shape tell us how many rows and columns our data frame have. Okay, for example here we have 15 rows, because in data frame rows start from number 0, so the last one is 14. Okay, but if you count them, these are 15. And 9 column, 1 2 3 4 5 6 7 8 9. Okay, that's it. So here, as you can see, the data frame which we created from with dictionary, we generated, and we can use it for our next tricks. Next, trick 2, which is pd.at and brackets. What this does is it optimize for reading and writing a single value in our data frame. For example, this is our data frame and we want to change this value only. For example, imagine your client gives you a data frame from its customers and tell you that, for example, this value, this price is wrong. It should be 1,250. Okay, so you as a data scientist and data analysis, you simply can change this value by running, for example, here df our data frame .at, and for example with the first value is calling our row, for example the number 1 row, and the price, which is this one. Right now it's 80 and we want to give it 750. Okay, and before we run this we can check the value. Here we get 800, and after this if we print it we get 750. So we changed a specific value in our data frame. Next trick is pd.assign. It lets you create or overwrite multiple columns in a single expression. Okay, and it will return new data frame. It keeps the original data frame and gives you new data frame. Okay, so here for example I wrote df.assign discounted price. This is a new feature we want to generate with df.assign. It get df price cross 0.9 and total amount is price cross df quantity. Okay, and profit margin is lambda x. For example, when x in price minus x in price cross 0.7 dot round 2. Okay, if we run this and then print our data frame with head, we just see our first 5 rows. Okay, on default the value is 5, but you can for example give it value to 2 and it will only show you the first 2 rows, but by default it will show you first 5 rows. And here as you can see, now our data frame columns, we just want to see here if we use 2 brackets and write our columns, we just see these columns in our data frame. Okay, for example we have 9 features, 9 columns, but we want to only see 5 of them. So with 2 brackets and writing each feature in quotation, we can print these values in our output. So for example here as you can see discounted price, we print it, generate it. So for example if we come here, so the price is 1,200, but with crossing it to 90%, this is discount, the price turned to 1,080. Okay, so for example total amount is price cross quantity, which we I think added before. Here as you can see we added before. And a profit margin, which telling us for example how much profit it can generate. Okay, with this formula. Next is pd.query. If you are familiar with databases, you will know what query means. pd.query let us to filter rows with a string expression. Okay, so for example here as you can see, for example we say when our price value is higher than 500 and our number of quantity is higher than 1, give these rows into result variable. Okay, so we use our main data frame and generate new data frame with these values. Okay, so this is one way you can do it, and another way which is df.query. Instead of writing separate parentheses, we just write inside quotation price higher than 500 and quantity higher than 1. It's simpler than this one, and we can just print it here. As you can see, out of the data frame we had with 15 rows and 9 columns, we can see that only these rows have quantity higher than 1 and price higher than 500. And also we can instead of writing, for example, values like this, we can give them a variable and then call them with @ and then the variable name. Okay, so here, for example, this is equal to, for example, writing the integer number 500. Okay, for example, if our code is larger, you want to define the variables, you can also write it this way. Next is pd.log. It lets you filter rows using a string expression. Okay, so rows are vertical lines. We call these rows. With pd.log we can filter these rows. For example, here we can see df.log, and in the brackets, when price is higher than 1000, and give it a column price tier and the value premium. So when in our main data frame, when the prices are higher than 1000, these products are premium, and we give them the name premium in a column price tier. And next, when the price is higher than 500 and equal or lower than 1000, we give them mid-range. These prices are mid-range. And when the prices are equal or lower than 500, we give them budget name. Okay, and then we can print our data frame and see here. As you can see, for example, laptops which prices are higher than 1000 are premium. Phones which prices, for example, around 750 are mid-range, and monitors which are the cheapest 300 are called budget. Also, we can if we have two rules, for example, here with np.where we can say where prices are higher than 1000 true, else false. Okay, it's a boolean type. And if we generate our data frame, you can see that the is expensive column feature is true when the price is higher than 1000. Price higher than 1000, and false when the price is lower than 1000. And here you can see price tier, it's premium because price is higher than 1000. The next one is mid-range because it's higher than 500 and lower than 1000, and so on. Next trick is pd.drop duplicates. Let me fix this typo. So when you're working on data frames and data sets, there may be rows which are similar. Okay, for example, the client simply add same customer 2 times, 3 times. Okay, for example, let's see here. For example, we print our data frame shape before dropping the duplicates rows. Okay, and when we put a number in the brackets with df.shape, we are simply saying that we just want to see the number of rows. If we here write 1, it will only show us the number of columns. Okay, with 0 it will show us the number of rows. And with df.drop duplicates, and based on order ID, which are these columns. So for example, here, and we keep the first one. For example, if we have two rows with similar order ID, which is pointing to one person. Okay, for example, if we have two 1001, these are for one person, so we drop one and keep the first one. Okay, we can, for example, here write keep second one or third one based on our data frame. And then after we drop the duplicates, we give them a variable clean data frame. We print the shape of our number of rows with our clean data frame, and then we print to see how many rows have been dropped. We run this. Here, as you can see, previously we had 15 rows. Now after dropping duplicates, we have 13 rows, and 2 rows was duplicate which we removed. Now we can print our data frame. Here, as you can see, this is our data frame after we removed our duplicates column. And after we print our clean data frame, here you can see, for example, we don't have number 10 here. Okay, or for example number 11. And if we look at our original data frame, for example number 10, order ID is 1002 Bob, and if we find it here, for example in the second row, 1002 and Bob, these two are duplicate, so we remove the first one and remove the second one and keep the first one. And also, for example, row number 11, 1005, for example, here again, as you can see, we had this column, so we removed it. So we remove the rows based on our subset is order ID. Okay, so for example here, as you can see, the price here is 8,000, but here is 750, but we remove the duplicate rows based on order ID. If we want to remove based on prices, we should mention it here instead of let me find it. Instead of subset order ID, we should write price here. Okay, here as you can see, for example, we can also use keep false. Okay, and here we print our duplicates column. So for example here, these are column, these are data, this is data frame without duplicate columns, and here we want to print our data frame with duplicate columns. So here, as you can see, Bob, and all are Bob, and for example this is the number 10, row number 10, and also here number 10, and this is number 11. And also, for example, and these two lines are the lines that these lines are the first line we keep. Okay, and here, as you can see, these two have been removed and these two stayed, but these 4 lines are the duplicate lines. Okay, because we we added false to keep, we can see all 4 rows, but 2 of them stayed on our data frame and 2 of them removed. Next trick is pd.groupby and pd.ag. Let me fix this first. These two commands let us compute multiple statistics per group in a single line of code. So here, for example, we use our clean data frame with groupby. We group our products, and with aggregate we add some value. For example, total quantity is our quantity column and the sum of the values, average price the price column, and the mean of all prices. Max price, we use price column and the maximum number between price. Or order count is order ID and how many order ID we have. And total value, for example, our total amount column, and sum all of them and round it to 2. If we run this command, we can see with groupby and aggregation, we used our product, for example, laptop, monitor, and phone, and these columns we generated. For example, the total quantity, the number of laptops we have in our data frame is 6. We have 7 monitors in our data frame, and we have 9 phones on our data frame. The average price for laptop is 1,200. Average price for monitor is 300. And average price for phone is near 800, 787.5. And the max price for laptop, the most expensive laptop, is 1,200, and monitor most expensive one is 300, and for phones is 800. And for example, you can see also other features, order count, how many out of our all data frame, how many of them are for laptop, how many of them for monitor, and how many of them are for phone, and also the total revenue. For example, by selling laptops, how much revenue a client can make, or by selling monitor or phone, how much revenue they can make. Next trick is pd.pivot table, which transform long form data into a cross-tabular view and making it easy to find patterns across two categorical dimensions. I ran this column before. So for example, here we called our clean data frame and .pivot table. We use index customer. Here as you can see, our index is customer column, and then columns are product, laptop, monitor, and phone, and values are total amount, and aggregation function is summing all the total amount. Okay, and if we have no value, we give it 0. Okay, so for example, Alice customer, the total amount they pay for laptop is 1,200, for monitor is 600, and for phone is 2,400. For example, Bob didn't pay anything for laptop because Bob didn't buy any laptop, so the value is 0, but he paid for monitor 300, he also paid for phone 1,500, and so on. Next trick, number 9, is using pd.nlargest and pd.nsmallest. I forgot the n here, which returns the n row with highest or lowest values in our column. So here, for example, we call our clean data frame number of largest, 5 number of largest based on total amount, and we want these columns to appear. Okay, so the first 5 highest total amount in our clean data frame, and these columns. Okay, if I print it, you can understand it better. So for example, here this is our clean data frame. We want to get the highest total amount price in this column, total amount, the 5 highest one, and then give these 4 columns of it. Okay, with nlargest we get the 5 highest total amount value in our clean data frame. We want to see these columns of our that columns. Okay, and the next one is nsmallest. For example, we want to see the 3 smallest total amount value and these columns, these features. Okay, if you go and check, if you want to find the 3 smallest total amount value, it's a little hard. If our data frame grows and become larger, it's very hard to find this value from a simple data frame. But with these features pandas give us, we can easily find values. For example, here we see 3 lowest total amount value and these column features. Okay, so the columns which has the lowest total amount are, for example, Bob, which about 300, which is about for monitor, and Alice about 600, and Eve about 600 also. So these are the smallest. Another way we can sort our value is by using dot sort value and then ascending false or true by, for example, total amount, and dot head, which give us the first 5 row. Okay, this command is similar to using nsmallest or nlargest. Here when ascending is false, it means we are showing us the largest value. If we change it to true, we will get the smallest one. And these two are similar, but for large data frames I suggest you using nlargest and nsmallest. Next trick is pd.cut, which converts a continuous numerical column into discrete buckets. Very good for segmentation, reporting, and feature engineering. Here an example. For example, we generate new feature in our clean data frame. We call it spend tire, and with pd.cut we use the total amount column in our clean data frame, and we generate bins. For example, the first bin is between 0 and 500. The second bin is between 500 and 1000. The third one is between 1000 and 2000, and so on. And we give it labels. So between 0 and 500 is low, spend tire is low, between 500 and 1000 is medium, between 1000 and 200 is high, and between 2000 and infinite is very high. And then we can print this data frame, and we just want to see these columns out of our data frame, the one we generated right now, and total amount, the column we used to generate this new feature, and the customer, and we print the first 8 rows. For example, Alice total amount is 1200, which stay between these two, between 1000 and 200, which is high. So spend tire is high. Then Bob is 1500, again it's high, and so on. And with dot value const and sorting index, we can order our customer to see how, for example, the spend tire, we want to sort our values and indexes based on spend tire feature. So for example, we have just 1 low tire, 4 medium tire, 5 high, and 3 very high. You can see here we just print the first 8 row, but for example here you can see with first 8 row we have 3 high, we have 1 low, we have 2 medium, and we have 2 high. If I print these columns without head.height, all of them, we can count it here. We have 3 very high, correct. We have 4 medium, correct. We have 1 low, correct. And 3, 4, 5, and 5 high. So we get correct values for this sorting index and value counts. Next trick is pd.explode. So it's very important. In real world dataset, you may see often, for example, a value has a list like values in a single cell, okay? For example, tags, categories, or product. With pd.explode, we can flatten these into individual rows. It's make it easier for our query. For example, here, this is our data frame, and in tags column we have a list. Okay, this is not one value, it's a list of values. With pd.explode we can turn this column into two, one with, for example, laptop, and next row with premium, or for example phone and mid-range, laptop, premium. Okay, and based on the data frame we can use each row as another feature. Okay, here for example we called our clean data frame, which is the data frame after dropping our duplicate column, duplicate rows. So for example, we use these 3 columns and explode tags. Tags is a column which we see earlier that has list of values. We print it, and here, as you can see, right now we have two same order ID, for example, one with laptop and one with premium. Then second one is 1002, one is phone and one is mid-range. And for example, here we can check how many orders we have with premium tag. Okay, for example, we have multiple tags. We can see how many premium tags we have. We name the variable exploded. We can say exploded, and in the brackets exploded tags equal to premium, and the order ID is unique. Okay, so for example, with one row, the list of values both are premium. With n unique, we count them as 1. Okay, and we print it. We can see that we have 5 premium tag. For example, if we want to get another thing, for example, we can see print exploded, and inside it tags dot n unique. We have 6 different tags. Okay, for example, we have laptop 1, 2, 3, 4, 5, 6. Okay, if you check all the data frame, if you count it, we have 6 unique tag. Okay, and if also we can use print exploded tags dot unique. We can see the list of strings about each one is unique. With n unique is number of unique, and unique is the values itself. And the last trick is pd.memory usage and pd.asType. On large datasets, the default pandas d types will using significant memory. Decreasing it to smaller types can reduce the memory usage by 50 to 75%. For example, here we print clean data frame, we use our clean data frame dot memory usage, and after that we see, for example, here we can see each column how much memory is using. So for here we call clean data frame memory usage, so it will show us each column how much memory is using, and we print the total value, which we can get it by summing all this value. We can see that total is 5.67 kilobyte. So, and then here, for example, we can change our columns type. For example, our order ID, which is integer, we can change it from int 64 to int 32, which will reduce the memory usage. Or for example, our prices, our float, we can change it from float 64 to float 32, and the quantity from int 64 to int 8. Okay, and for example, our category columns, for example, here product, we can change it to category. Maybe it was not. Here you can see that if I df dot I forgot it, I think. df.info. For example, here, as you can see, for example, our product has an object D type. Okay, we change it to category, so it will reduce the memory usage. Origin is object, we change it to category. Or price tier, right after we generate it, has object data frame type, we change it to category, and then we check how much memory usage this data frame have after changing our data types. Here, as you can see, 4.34. So we have some improvement from before. And the last one, we can write a function which do all this in a simple function, instead of, for example, writing each data frame, each column separately with this function. We are telling that, for example, if in our data frame, if for each column in our data frame, if it has int 64, change it to int 32. If, for example, in each column in data frame has float 64, turn it to float 32. And also, if each column in our data frame has object data type, turn it to category. With this function, we can write this function, so for larger data frame, makes our job easier and faster. That's it, guys. Here we saw 12 tricks in Pandas, which is very important for data scientists and data analysis workflow. I hope you like it. You can also run all these commands yourself. You can use it on my GitHub account or on my website and test it and learn these. Also, you can simply on Google search Google Colab. If you are not familiar with Google Colab, you can search Google Colab and click on this first line, and here you can simply click on new notebook, and an empty notebook will open, and then you can simply come here and copy this line, paste it here and run it and see the result. Thank you. like this video, subscribe, and leave a comment and tell me your idea about this video. Thank you. Bye for now.